everybody. So in this video, we're going to be talking about compound inequalities. So here they want us to solve, graph, and write the solution to each inequality in interval notation. So here we have a compound inequality. So you've actually have a lot of experience working with compound inequalities that use the word and, because you heard riddles like this growing up. So if somebody said pick a number between 1 and 10, you can pick numbers 1 through 10, but you couldn't pick anything outside of that output. So you couldn't pick the number 12, you couldn't pick the number -3, because they're not part of that compound inequality. So anytime you see and right here, the compound inequality is bounded. So it has a specific beginning and a specific end, and all the numbers that go or that fit or satisfy that inequality fit in between this lower boundary and this upper boundary. So let's see what those are. So to solve this, we're just going to work with each of these like they are individual inequalities. So we'll start by subtracting 7 here. So we have -7, -7, and then over here we'll add 8. We'll kind of solve each of these at the same time because these aren't too bad to solve. So here we now have 5x is less than or equal to 47 minus 7 is going to give us 40. And then here we have -4x is less than or equal to 12 plus 8 is 20. And then we're going to divide here. So we have x is less than or equal to 8 and x is greater than or equal to -5. So remember, anytime you divide by a negative number, the inequality changes direction. So that's what I did here. So now let's think about this. Any number I pick needs to be smaller than 8, and any number I pick must also be larger than -5. You can't forget about that word here, and. So any number I pick must be smaller than 8 and larger than -5. So let's think about that. If I'm at -5 here, that's the smallest it can be, and remember this is greater than or equal to, so here we want to fill in this circle, and we're going to do the same thing at 8. So over here at 8, we're going to draw a circle, we're going to fill this in, because I can pick 8 and I can pick -5, but the numbers must be in between them. So here my solution would be in between -5 and 8. So that's how our graph would look. Now in interval notation, this is going to be the smaller number first, -5, and it's going to go up to 8. Both of these get brackets because both of these numbers are included in the solution set. Now with and, you can see compound inequalities with and multiple ways. So here, this is one way where they write out and. Most of the time you'll see it written something like this. So I'll have my x here and it will be bounded in between these values. Now solving this isn't going to be bad because we want to know what is the lower boundary and the upper boundary. We don't want to have to worry about this right here. So here's what you do. All you have to do is isolate the x. So we'll start by subtracting 1, and we have to do that to both boundaries. So here we'll subtract 1, so -1 minus 1 is now -2. So -2 is less than 2/3 x, which is less than or equal to 5 minus 1 is 4. And now we want x by itself. So what we'll do is we'll multiply each side by 3. 3 times -2, this gives me -6. It's less than or equal to 2x, which is less than or equal to 12. And now I want x by itself, so I can go through and divide everything by 2. So now I have -3 is less than x, which is less than or equal to +6. So I'm telling you to pick a number that is larger than -3, but smaller or equal to 6. So that's my boundary. So here at -3, this is going to stay open because of my inequality. And at 6, I can pick the number 6. So that will be a closed circle. and I can now select any value in between this range. So here I'll get my ruler. So here, any value in between that range would satisfy. That's my graph. Interval notation, because -3 is not included, that will be a parenthesis. And because 6 is included, we'll give that a bracket. So that's a compound inequality. That's an and compound inequality. So they use the word and. If they use the word or, it is also a compound inequality. So let's think about this. Here, we'll begin solving. So we'll have to distribute this -3, and that's going to give us -6x minus 3 is less than -15. And then here we also have -x is greater than or equal to 5 minus 1 is 4. So here we're going to add 3. And we have -6x is less than -15 plus 3 is going to be -12. And then this is not changing. So here, or -x is greater than or equal to 4. So here I'll divide by -6. And remember, when you divide by a negative, your inequality will then change. -12 divided by -6 is +2. Here, x will be less than or equal to -4. So I want a value that is larger than 2 or smaller or equal to -4. So here we have -4 that is included, and x must be smaller than or equal to -4. So here I can show all values to the left of -4, or I can pick a number that's larger than 2. So I can't pick 2 because it says it must be larger than 2, or it could be any value that's larger than 2. So here, going to the right. With interval notation, anytime you have or, you're going to have 2 separate intervals. So I'm coming from the left, from -infinity, and I stop at -4. So remember, we can never include infinity. I stop at -4. -4 is included. So I get a bracket, and then I am going to join by saying union. That's what this symbol is. And I'm going to include my second interval. 2 is not included. It gets a parenthetical. I'll say 2 or any number larger than 2. And this would be my inequality in interval notation. All right, I hope that helps. If you have any questions, please leave them in the comments, and we'll see you all in the next video.